All right, so really, first thing I want to open with is the whole elephant in the room, right? Being if you're familiar with NGS and who we are and what we do, then you've probably already heard the, there we go, that our modernized NSRS that we've been planning on rolling out in 2022, we've had to delay that, okay? So I took a few of our frequently asked questions that we've gotten about that, put them on just a little intro slide, just because I know that a lot of folks have been asking these same questions. So we're really talking about 2024, 2025 is when you'll see the new datums roll out, is our approximate timeline now. And the other question we get are the names going to stay the same? And yes, all the 2022 is going to stick, even though it's going to be a few more years until these roll out, okay? So for those that aren't really familiar with NGS, I like to start out with who are we? You know, what part of the government are we with? So we're really, interestingly enough, we're the federal government's oldest scientific agency. Okay, we've been around in some form since 1807, but currently we reside in the executive branch of the federal government as part of the Department of Commerce. Further down the chain of organizational charts, you see NOAA, and then the National Ocean Service, and then way down below that, there's us, NGS, the National Geodetic Survey. We've got about 175 folks at NGS out of almost 50,000 in the Department of Commerce. So, you know, we're just this little tiny agency trying to do big things. And so when I talk about who we are, I like to talk about who we're not, because I get a lot of confusion. People think that we're USGS, and so I just like to point out we're not USGS, we're NGS. USGS is part of the Department of Interior, and they're kind of, you know, very separate from us. But we do work, try to work as close as we can with them. I keep in touch with my national map liaisons, and really do try to stay in touch with USGS projects, or I lost my train of thought there, but I try to stay in touch with their goings on, right? So if you think about us, right, I'd like to talk about us in relationship to the National Flood Insurance Program, okay? So like old Troy McClure there, right, and we're NGS, and you may remember us from different documents, right, like Section 6.1 under FIS Reports. Any firm or digital firm that you've seen, you'll see a reference to us. And then even the NFIP, the CRS Coordinator Manual, right? The community, well, it's just, I wanted to break down all these acronyms, right? That's another thing I noticed. I give presentations, I've sat in presentations, and it drives me bonkers when people don't explain acronyms, right? We're here to learn from each other, so I wanted to just break down all this mishmash of acronyms that you've already seen in the slides, right? So here we go. NFIP, right? You probably know that one. FIS, that's your flood insurance study. The FIRM is your flood insurance rate map. The DFIRM, which is typically what are produced now, it's just a digital version of the FIRM, okay? And the CRS is the community rating system, or what FEMA has is a series of discount or credits, or somewhat like a discount for communities that participate in that CRS, okay? And so as we talk about that FIS report, and I say you'll see us in the FIS reports, right? Where do you see us? In section 6.1 of your typical FIS report. This is just a copy of the current template, right? It's the section though on vertical and horizontal control, okay? And that's where you should find information specifically on the vertical datum used to, that was the data was collected in, and that the firm was published in or developed in. And you'll also see some information on horizontal datums. What else will you see? If there were any conversions performed, right, as a part of this FIS report, right, like using older data or utilizing maybe a USGS quad, you're going to see maybe a table 20, right? or Table 21, okay? And those are broken down and explained in the template FIS report. There's even a whole separate FEMA technical manual on performing one of these countywide vertical datum conversions and a stream-based vertical datum conversions, okay? And so that's where you'll see references to NAVD88, NGV29, and then the National Geodetic Survey. Specifically, FEMA typically calls out, if you have questions regarding that conversion between the two, right, NGV29 and NAVD88, here's the responsible agency to contact, okay? Where else are you going to see us mentioned in regards to NFIP? In the notes to users on anytime you're looking at a firm or a DFIRM, right? So what are you going to see? Let's kind of blow that up a little bit. Our notes to users. You're going to see some information. Whoops, kind of messed that up there. But you're going to see information on the horizontal datum first, right? So NAD83 typically. And then that second paragraph, you're going to see information on the vertical datum. You could see NGV29 or NAVD88. Regardless, you'll see, again, NGS designated as that responsible agency. You'll see some website and telephone information. But we always invite, any questions on vertical datums or converting between the two. Always happy to try to answer those and point you in the right direction. And where's the last place I'll mention that you see us in regards to NFIP? You'll see us in that CRS Coordinator's Manual, okay? Specifically, you'll see us in Activity 440, Element 442.c, which is benchmark maintenance, okay? And this is one of the credits the community can get discounted rates on by conducting inventories of conventional benchmarks, right? The disks in the ground, right? But what I want to point out is this section down here on GPS support, okay? This is what I really like to point out about the BMM or benchmark maintenance, because FEMA has been kind of forward thinking or forward looking on this topic, in that I'll blow that up right there for you. That section or that activity in the CRS Coordinator's Manual already includes provisions for a CORS network, right? To replace these benchmarks on the ground, right? These conventional disks that you would see mounted in concrete or affixed to the side of a building or something, right? So this has been around in the CRS Coordinator's Manual for quite some time. And I really like to highlight that to show that, FEMA has been embracing this along with us, utilizing these CORS or continuously operating reference stations for positioning for quite some time. And so as I talk about the transition to more focus on CORS, right? I just kind of want to point out that this is not something brand new, okay? So if you're not familiar with continuously operating reference stations or CORS, what is that, right? Well, let me just pull up this little photo. So that's a CORS, okay? This is a GNSS or a GPS antenna. In this particular instance, it's mounted on the top of a building. The cable from the antenna runs down into a receiver in the building somewhere. And this station, or CORS, logs data 24/7, 365, okay? And what happens is the data is uploaded to the internet and provided to NGS, us, and we serve it out about 2,000 sites from over 200 organizations every day of the year, okay? We provide access to this data. Kentucky, right down around in here, quite a good density of CORS across the entire state. And we'll talk a little bit more, about CORS as we move along, and you'll see that graphic, that map again, okay? So jumping around a little bit, I try to talk about FEMA, where you'll hear us in relationship to NFIP documents and documentation, right? So again, let's back up to who is NGS, right? And what's our mission? Showed you a little bit about where we reside in the whole grand scheme of things, but our primary mission right here is really the red. Maintain that NSRS, okay, and provide access to it. What's the NSRS? It's that National Spatial Reference System, okay? What does that mean to me, Jeff, right? Is maybe what you're thinking if you're not familiar with it. I like to think of it, this nice little bullet sentence here, common and consistent geospatial framework, okay? Comprised of what, right? Well, the framework of latitudes and longitudes, that kind of go hand in hand, right? Heights, elevations, as some say, scale, meaning your length, your unit of measure, orientation, meaning your grid north or your magnetic north, which NOAA contributes to the geomagnetic or the Earth magnetic model. And then, of course, gravity, which is used to build the height datums, okay, or the reference surfaces for vertical datums, okay? So the NSRS is a consistent coordinate system that defines all of these things, right? And you saw this pop up, how they change over time, okay? So let's look at some datums or items that are part of the NSRS, okay? I want to highlight these few right here. These are what you're probably familiar with. NAD83, NAVD88 specifically, and then NAD27 and GBD29. You may or may not have heard of Geoid 12B and used that Geoid model for deriving orthometric heights from GPS data. But I would like to point out we do have our brand new, or very recent anyways, Geoid model. This is Geoid 18, okay? Now, as I talk about what is part of the NSRS, I do like to briefly point out what's not part of the NSRS, okay? And I specifically just point out WGS 84, okay? It's not part of the NSRS. It's wholly its own entity, its own reference frame, developed by the Department of Defense, another agency, very similar acronym. They're NGA. We're NGS, they're NGA, the National Geospatial Intelligence Agency. They are responsible for WGS 84, okay? I can typically answer some questions about it, but you know, it's not our product here at NGS, okay? So within the NSRS and the vertical datums, you're gonna see three different types of vertical datums, all right? The real basis or baseline are ellipsoidal datums, right? And this is really the native vertical datum of any GPS observations, okay? Sure, your GPS receiver may apply a geoid model to an ellipsoid height to get you an orthometric height, but the native heights that you will get from a GPS receiver without using a geoid model are ellipsoidal heights, okay? Same for raw LiDAR data and these raw hydrographic surveys, all right? Orthometric vertical datums is what we're familiar with, NAVD88 and NGVD29, okay? And that's what you see the USGS quads published in, FEMA data, right? Any of your NFIP data or maps, your firms, they're published in orthometric datums. And when you're out using, or you see someone using a conventional surveying instrument, such as an automatic level like this, or even a total station, those are working in orthometric vertical datums, okay? And this is, again, commonly known as elevation, all right? There's a third type of vertical datum that's really does come into play when we talk floodplain mapping and NFIP, and that's a water level datum, or along the coast, a tidal datum, okay? And right here, I like this little diagram of, it's kind of like a cross section of a stream gauge, okay? Here's our little stream with a water surface. And what the gauge records is basically just these assumed, you know, calling something zero and recording that, right? This is 0, and this is, you know, normal water level is 5.0 feet, right? And then what happens later is some reference monuments near this gauge are surveyed in, probably with GPS, and then we can relate these assumed water level datums to our ellipsoidal and thus our orthometric datums, okay? So that's our third type of vertical datum. The NSRS is our water level or tidal datums, but not typically thought of, but really we focus on our ellipsoidal and our orthometric. I like to think of it this way, is that your ellipsoidal datum is your bridge to your orthometric datum, right? And under that bridge, there's a little geoid model. Instead of a troll, there's a little geoid model to help you get to that orthometric datum, okay? So let's talk a little bit more about that orthometric side, all right? And so where does the NSRS fit into this, right? When we talk about that orthometric datum or that elevation, right? Where does the NSRS fit into that firm? Well, I'll tell you where. It's really due to the fact that, the creation of firms requires the use of independent data, right? You're looking at LiDAR data typically for your dry sections, right? Or your stream banks and beyond. You're combining that with wet cross sections, right? They're typically surveyed conventionally or maybe with GPS, right? And built into some software like HEC-RAS or GeoRAS or something like that, right? And then you're combining all of that information, these two sources, with historical gauge data, right? This is a hydrograph from USGS. So just here, you're gonna typically have data from 2 different federal agencies and some other source of LiDAR data, which may be probably privately contracted. We've got a lot of great aerial contractors, a few based right around northern Kentucky and central Kentucky, southern Ohio, right? So you're combining data from all these different sources, but to build that firm, you got to know what? You've got to know the datums. If they're not all on the same datum, you at least have to know what that datum is so you can perform that conversion or that transformation, okay? To align these, combine them, and build that final product, right? That firm, something that's accurate, okay? So that's where the NSRS fits in, right? Is that all federal agencies are required to use the NSRS, the National Spatial Reference System, for developing all their geospatial data, right? So as a part of what we're working on at NGS is NSRS modernization, these new datums. I want to point out that it really is more than just new datums. That's all I'm going to mention here, really. I might mention a new tool, but really I'll just mention new datums because that's the most relevant item to anyone working on floodplain mapping. But do note that a part of our overall NSRS modernization includes a lot of other new facets of the NSRS, okay? And so the modernized NSRS, there's 2 major components. Well, there's 2 major components of the existing NSRS really too, right? And I pointed out right here, I want to highlight that our geometric component and our geopotential components are related to NAD83 and NAVD88. And I kind of threw these in here last minute because what I want to point out when I talk about the geometric component, which I'll briefly cover, we've historically referred to it as our horizontal component. But I found in my time with NGS that that's confused folks because remember I talked about that ellipsoidal datum. That's a height, right? It's vertical datum, but your ellipsoidal height is a part of the geometric component, okay? Your ellipsoid height is part of NAD83, all right? It's your orthometric height that's part of NAVD88, okay? That your geopotential, all right, or your elevation. So I kind of threw these in last minute just to really bring that home, that I want to point out. Just remember that your ellipsoid heights are part of NAD83, okay? And so I want to talk more though about our orthometric heights, okay, and our future geopotential data, all right? So let's kind of back up a little bit. We're going to back up a couple times and talk about a little bit of history. So NGVD29, right, it was replaced by what? NAVD88, right, North American Vertical Datum, 1988, which will be replaced by what? The North American Pacific Geopotential Datum of 2022, or we like to refer to it as NAPGD, okay? So we created the acronym, we can tell you how to pronounce it, right? So NAPGD 2022, all right? That's the future geopotential datum. And people say, well, what's this word geopotential? It's really, without getting too much into it, it's really a more scientifically appropriate way of saying vertical datum due to the way that vertical datums are designed and built these days, okay? So you can really think of NAVD88 itself as a geopotential datum, but now we're just trying to get things right from a terminology standpoint, okay? So NAVD 2022. What's the biggest difference you're gonna notice when comparing NAVD88 to NAVD 2022? Biggest difference I think most folks are gonna notice is that we will have gotten away from relying on passive control. And what does that mean, right? What are you talking about, Jeff? What's this passive, right? Well, passive control was how our NGBD 29 and NAVD 88 initially were realized, okay? It was a set, a giant network of conventional surveys run across the country, across the lower 48, and all tied together and processed and adjusted, right? So you set these marks, discs, or monuments in the ground or in some structures, right? We call them passive though, because in the vast majority of instances, these things were surveyed one time. You know, they were set, surveyed, and that's it, right? So they get installed, surveyed, and then they just sit passively in their setting or whatnot until what? Until they're destroyed or vandalized or stolen, you know, or any number of things, right? So we recognize that we're in a constant battle with the destruction or disturbance of passive control, right? That most often only gets surveyed one time. We've got to move away from that, okay? So what are we moving towards? Well, you may have guessed it, you may have already heard about this, right? What's the opposite of passive? Active, right? So we're moving to active control. So what's that mean, right? Well, we call it active because it refers to this GNSS receiver that does what? Collects and logs data 24/7, 365. So what's in this picture here? This is a CORS. This was out in, I think it's Bowling Green. I don't remember. But yeah, this was, I believe this is a CORS outside Bowling Green. A beautiful setup here, big concrete. So this is a monument, but we call it, and this is survey control, but this is active, okay? Why is it active? Because that antenna, right, that GNSS or GPS antenna stays affixed to the monument and logs data all the time, right? And so what happens is, if the monument moves, right, if the antenna moves, we can quantify that. We can observe it by comparing the motion to previously calculated positions, okay, whether it be daily, weekly, or even annual positions. All right, we could see by looking at weekly positions, movement throughout the seasons, perhaps, you know, maybe not, you really can see some, even in Kentucky. I don't know about specifically Kentucky, but I know even in Southern Ohio, we could see some vertical motion seasonally by examining this CORS data, okay? So what is another great thing about active control? Well, the big great thing about active control is the convenience factor, okay? There's no need to, I'll skip back real quick, go out and recover or look for an old conventional monument to tie into the datum like NAVD88, right? We simply set our own monument. Could be just a wooden disc or a wooden hub in the ground, or even just you know, utilize a chisel mark in a sidewalk or something, right? Meaning you set your own, you collect GNSS data on it, GPS data, and you use this CORS data to calculate your differential position of your newly set monument or newly observed monument, right? No need to go out, try to recover something that's likely gone to tie your project into accurate control. We've got these CORS all over the country, so we want to embrace that idea of active control. So how many CORS are there? Again, it was about 2,000. There's that map again of CORS. Over 200 organizations participating, including at least 3 in Kentucky, the KYTC, and then a couple universities, right? at least 3 organizations, but numerous stations, right? And so when we talk about cores, the stations are, each one of these points on the map represents a station, but the system as a whole is what we call the NOAA Cores Network. We've got 2 acronyms within an acronym, right? Isn't that awesome? The NCN, right? So you get the NOAA Cores Network. Okay, I think that's a first for me. 2 acronyms within an acronym, right? So looking at the combination of all the cores is where the network is what the name for that network, or NCN. Okay, that's kind of a new term for us, so I kind of like to point that out. The NCN, you'll start to see that, and that refers to the network as a whole. Okay, each one of these is still a cores or a station. All right, which looks like similar to this. Okay, so let me skip back forward. So now let's talk a little bit about datums and the situation that we're in, why we care so much about active control, right? Well, I like to mention that in a perfect world, your datums will be parallel and smooth. Maybe this doesn't make sense, this bullet, to you right now, but I want to guarantee it will by the end of my presentation. That's my goal, is to kind of break down the concept of a vertical datum from kind of start to finish, okay? So in a perfect world, your datums would be parallel and smooth, but they're not. Errors in measurements would not exist, but they do, right? Adjustments of survey data, kind of getting down the nitty-gritty, they would all align, but they don't, right? And really, the surface of the Earth would not move. But I got news for you, right? This just in, folks. We don't live in a perfect world, right? So we have to deal with all of these items, all right? Specifically, this bottom bullet, surface of the Earth, right? Plate tectonics, and even just regional subsidence. And the fact that our existing vertical datums are neither parallel nor smooth, okay? So now we're going to back up a little bit just to get the concept of a datum, or how to compare data in different datums. I put these slides together with some help from another advisor for the Michigan Stormwater and Floodplain Conference, and they really liked it. So I thought, okay, I think this would be great to keep going with. So I kind of built on that and did some more. So let's visualize a vertical datum and the difference between 2 vertical datums. Okay, so what is this vertical datum, right? How can we define it in regular English? A reference surface that can be used to measure heights in a uniform way. Okay, as such, right? So let's say we want to measure, we want to compare the heights of Sally and Jane, right? How much taller is Sally than Jane? We could measure from the top of Jane's head to the top of Sally's head, right? Sure, we could do that. And that's a relative height or a height difference, all right? That's one way we could do it. Or we can measure from the floor of the ground up to the tops of their heads, and then subtract, right, to get that difference. That right there would be using a datum, right, or a difference in heights above a datum, right? Okay, so in this case, the ground of the floor that Sally and Jane are standing on is the datum, okay? So we can calculate the difference in height because they're on that same datum. All right. So what about in this case where we don't necessarily know what's going on behind the scenes, right? So we peel that back and let's look at what's going on in this case. We're visualizing that datum difference, okay? And the fact that Sally and Jane are not standing on the same surface, okay? We could still calculate X looking at measuring the height difference between Sally and Jane, but it doesn't mean anything. It's not accurate, okay? Because why? Our reference surface is not the same. It's essentially 2 separate datums, okay? So to truly know, accurately know how much taller Sally is, we have to know what they're standing on, all right? This is the same situation as comparing an NAVD88 height to an NGVD29 height. We cannot compare heights that are measured from different reference surfaces, okay? just doesn't work. It's, you know. So, but how would you do that, right? What if I do need to do that though, Jeff? I need some tool. Isn't that what you're supposed to do with NGS? Absolutely. We provide you these tools, right? And I will point out that although you hear the word conversion used throughout, you see it throughout FEMA documents and even in a lot of historical NGS documentation, the true terminology for moving data between two different datums is called a transformation. Okay, so converting, quote unquote, from NGVD29 to NAVD88 is really called a datum transformation. I'm not going to harp on it. I do just like to point it out because we are moving towards unifying our speech, and so you'll see us using this term now, datum transformation, across our documents, trying to really be scientifically appropriate. Okay. So we do give you the tools to conduct these datum transformations, right? We've had for many, many years this tool, VERTCON. Okay, you go to this very basic looking website, you key in a latitude and longitude and an ortho height. We spit out from an NAVD88 height, we spit out a 29 height, or vice versa, right? Whatever you want. Okay, VERTCON, great, right? The other cool thing you could always do with VERTCON is just leave that orthometric height entry blank, and you will get what output? You'll get the shift value, okay? So if you don't know a height, or you're not trying to convert a height, you're trying to determine how to shift your existing data in your GIS, you could always just enter 0 and get that shift value, okay? And as they say on TV though, but wait, there's more. If you call now within the next 37 seconds and order with your Visa or MasterCard, we're going to throw in a brand new tool for free, right? And what's our new tool? It's called NCAT, okay, or the NGS Coordinate Conversion and Transformation Tool, okay? And so why did I point out that word transformation earlier? Because when you use NCAT, you're going to get some results, and they're going to be segregated by conversion results and transformation results, okay? And so this is our NCAT homepage, right? As you'll see here, it's pretty simple to use when you get to the homepage. You're going to see some radio buttons. You're going to want to, you know, horizontal plus height. You're going to use orthometric to transform between what? NAVD88 and NGVD29. Again, right here is where you would key in an orthometric height, or you could key in 0 to get that shift value, right? You would click this convert button. What pops up is some results down here. What I like to point out is that's kind of new to NCAT. This didn't really exist in prior versions of VERTCON, was that you'll get the uncertainty of the shift, okay? You're gonna see it as listed as a sigma, okay? Your sigma ortho height. That's the uncertainty of your datum transformation, okay? And that's a great thing about NCAT that did not exist in previous versions of VERTCON. You're going to get some idea of how accurate was that datum, that vertical datum transformation, okay? But, you know, I talk about NCAT, and I show you this. I briefly, you know, have a slide where I talk about this single point conversion, but, you know, this is a GIS conference. I don't think many of you all are too interested in keying in, you know, hand keying in latitudes and longitudes, or even, you know, I guess I didn't point that out. You can also key in state plane coordinates or UTM, okay? It's not just limited to lat and long. You just need to change the radio buttons. But again, I don't think too many folks are interested in hand keying things in, so I'll point out two other options that we have. We have our multi-point conversion. We have these tabs at the top of the page. We also have a set of web services, all right, that I'll just briefly visualize for you. So let's look at that multi-point conversion. Very similar setup here. You're choosing some radio buttons, choosing your input vertical datums and output, same for your horizontal or geometric. And then down here, you're going to see an example of what NCAT expects you to upload. So you're going to click that choose button, right, to choose a file to upload. And here is what NCAT is expecting. It's kind of what we, the surveying community, or hell, you guys are familiar with a PNG EZ, okay? So meaning your point number, your easting, or your northing, your easting, and height, okay? But as you change this radio button here, you'll see a different set of samples come up, and it'll tell you exactly, instead of latitude and longitude, it'll switch to northings and eastings, right? And it'll show you right here below this wording sample file what the choose button is expecting, okay? And this would be uploaded as an ASCII format, comma separated, text or CSV, okay? What's our other newest option for NCAT? We've got these web services, all right? We've got some folks, I mean, I'm not quite as up to speed on utilizing these, but I can point you in the right direction, and I've got some folks that I can help answer questions on it. But if you look right here, you click this web services link, you'll end up on our NCAT, well, you'll end up on our NGS web services homepage, okay? Because we have more than just NCAT, okay? We have other web services available for other products, all right? But I'll just point out, there's the descriptions of input formats for these different NCAT web services are over here. And then just a quick shot of your results that can then be extracted once you run that, okay? So that's NCAT, replaced VERTCON, or really incorporated VERTCON, okay? So really it includes all elements of the newest version of VERTCON, which is version 3.0. And once we roll out the new datum, the new vertical datum, NAVD, it will include that too. So NCAT will kind of be that trifecta where you can go to transform your NSRS data into any other of the 3 vertical datums, okay? So let's look back at this image just briefly to think about this, right? What if Sally and Jane are growing, right? And we can't measure this height even at the same point in time? What if they live in 2 separate parts of the country and they never get together, so we have to take measurements at different points in time, right? Or what if things move? Or what if the Earth's surface moves, right? So I'm going to look at a case study from Alaska. Why Alaska? Because it's got a lot of land motion, okay? Let me get a drink here. Oh, and I just spilled water on my keyboard. I'll wipe that up there. Sorry about that. Of course, that's how it goes, right? All right, so sorry about that. So we're looking at an example from Juneau, Alaska, all right? And so we're looking at the bottom plot, right, is our sea level trend, okay? So the sea level is falling relative to the land, okay? Because remember, this is Alaska, so typically sea level is rising globally, right? But in where we're at here in Juneau, the land is actually rising faster, okay? So it's outpacing that global sea level rise, right? So you're getting this almost 2 centimeters a year of uplift. How do we know that? From a cores that's been running there since 2005 or potentially even longer. Not exactly sure, but it's been there outside Juneau. It's part of the NGS, or excuse me, the NOAA cores network, but it's run by a different agency, UNAVCO, the University Navstar Consortium, okay? And so over that time, since its observations have been collected and observed 24/7, 365, we know that the land is actually uplifting. Okay, we're seeing the opposite of what's typical, where you see mostly subsidence in the lower 48 in most areas. Okay, and so that uplift, we're able to measure it based on a cores there. Okay, this is another one of our regional geodetic advisors. That's Nick Kinsman. She's our Alaska advisor. Okay, and so what we're looking at here is in the blue, we're seeing that sea level is rising, right? That 2 millimeters a year. But what do we see in the red is that because we have that CORS data, we know this sea level rise from our water level gauges or our tide gauges, right? But we know this landmass is rising from our CORS. We see it's rising at 14, 15 millimeters a year, right? And so what's happening is that the relationship between this water level data and our geodetic data, right, our CORS data, right, is changing throughout time. And so to build an accurate firm in this area of the country, it's an extreme case that I point out because at this point with such drastic motion, it's extremely important that the datums, not just the datums are known, but the time that the data was collected is known, okay? And so that will become more and more important in the future as we embrace NAVD 2022. Why? One of the reasons, the primary reason is that it's working in NAVD will inherently be more accurate than working in NAVD88. Okay, whoops, back a slide by accident there. All right, so let's talk about, so we kind of covered that whole relationship of the NSRS to, firms and how data needs to be, aligned or referenced to the same, not necessarily the same datum, but we need to know the datums and know the times the data was collected. So let's look at why are we upgrading to NAVD 2022? Okay, what's this big investment of time and funding all about? Okay, why replace NAVD88? You got this great network of leveled benchmarks all over the country, the lower 48, right? Laid out how with a conventional or a digital level, call it automatic level. Very simple process of taking back sites and foresights across or through permanent monuments and temporary turning points, right? Great system. Why replace it? Well, I got these two graphics here. One, there's a nice disk in that one, right? But that's the whole point I'm trying to illustrate here is disks go missing. Again, they get destroyed, vandalized, whatever, right? So we know the community is tired of this limited access or lack of published benchmarks, easily accessible, right? That's one item. A few other things, subsidence, mostly in the lower 48, uplift in parts of Alaska and other areas of the country around the Great Lakes, and then just general freeze and thaw of benchmarks. Remember I said with CORS, you can see this seasonal freeze thaw. So maybe it's not that it's not happening with CORS, but it's active control those CORS are so we can see it and quantify it, okay? Also, this tilt or bias in the zero reference surface, that the datum reference surface. And that's what this graphic portrays. And you may have seen this about, my goal here in the next few slides is to explain what this graphic means, because I found that folks from NGS regurgitate this graphic frequently and people go, oh, what the heck that is? They go, oh, it's colors, great. So that's what I intend to do is kind of break this down. What does it represent? It represents the approximate error in the NAVD88 reference surface for what we call the zero elevation, okay? So to explain it, we kind of have to back up and look at a little bit of history, okay? So let's look at NGVD 29. How was it designed, right? It was referenced to 26 tide gauges across the United States and Canada on both coasts. All right. Trying to think of it. So, but what happened? What was the problem with NGVD 29? So let's get into that. But let's look at let's cut this cross section and picture all those gauges, right? Those yellow dots, tide gauges, and let's lay this down, right? So now we're looking at this in a cross section, right? Of here's our topographic surface. So here's our Pacific Ocean. Here's our Atlantic Ocean, and here's those, 26 or some of these tide gauges, okay? So this is our concept of how NGVD29 was built or designed. You basically took all the data, the water level data from these gauges, tried to figure out an average or a mean, and called that H equals 0, or made this your reference surface, okay? What was the problem? We learned years later that trying to take the mean of all these was a fallacy, or it wasn't really what we wanted. Why? What happened? We learned with better equipment and technology that mean sea level varies locally, right? At all these, due to what? Prevailing winds, ocean, all different things have influences, okay? So that was the issue with this. We meant to have this gray line be up here, but because of all these local variations, the average ended up whoop, down here, okay? The intent, though, like I said, was for it to be right up here. So now let's move on to NAVD88, right? So we realized the error of our ways with the 26 gauges, and we threw out 25 of them, and we held one fixed, right? And agreed on it with the Canadians, and we're using the mouth of the St. Lawrence River, Father's Point, right? It's a nice, beautiful lighthouse there. No, I've never been to it. I did not take the picture, but I tried to pass it off as I did once, and they knew I was just BSing, so now I admit it. So why the 1 gauge though? Because then we can remove that local sea level variation problem, okay? That was relevant or prevalent in NGVD29, okay? What did it not do? Well, what did that do though? It introduces something else, the possibility of this cross-continent error buildup. We're going to do the same thing with NAVD88. We're going to cut that cross section, we're going to lay it down, and we're going to look at that, all right? So same thing, Pacific Ocean, Atlantic Ocean, single tide gauge, right? Earth's surface. So what did we do with NAVD88? We cut it right through. It said, boom. All we got to do is fit it to 1 gauge. What happens though? This is that cross-continent error buildup. We hit things right on the money with the reference surface at the gauge, but as you look west, or specifically northwesterly across the country, you see this deviation. And if you want to look at this cross-section in plan view, that is what this graphic you see all over our NGS websites and other folks presenting, that's what this represents, okay? It's the difference between the reference surface, or that H equals 0, and compared to what, or how did we realize this? It was satellite gravity data, okay? Meaning, it's not like we knew this right away when NAVD88 was finished. It wasn't until the late 90s or early 2000s that there was enough satellite gravity data to build this map. So I have people say, well, if you knew it was messed up, why'd you do it? Well, it wasn't known right away, okay? But now that we know of this cross-continent error buildup, or this tilt, right, we want to address it. And the only real way to do it is to build a new datum. But I do want to point out that we kind of did know this was there, right? People say, oh, well, you did or didn't know. Most of this was intentional, most of this misalignment. And you say, what are you talking about? Why would you do that on purpose? Well, it was chosen specifically due to complaints from USGS, relevant complaints, right? They said, hold on, man, this was 91 or so, right? Hold on, man, we're required to use the NSRS as a federal agency, and we have to update all of our quads with new contours. That's going to take 20 years. You didn't have the GIS capabilities we do now to reprocess them so quickly. And so NGS folks work with USGS to pick this tilt angle to minimize the change to contours, okay? Believe it or not, right? And while we're looking at these slides, I want to do a relevant sidebar on geoids, because I run into a lot of folks on this topic too that say, I don't know about it, or if I really get that, right? So why do I want to discuss geoids? Because the fundamental way of building the geoid is going to be different in NAT GD 2022, okay? So here's a mind blow statement, right? There's 2 types of geoid models, not just one. Well, there's really more than that, but 2 types you'll see from NGS. You'll see us publish gravimetric geoids, and hybrid geoids. What's the difference? The gravimetric geoid is what makes the hybrid geoid, okay? Gravimetric geoid is created from scratch. The hybrid geoid is when we take that gravimetric geoid and we warp it. We mash it to fit or align to some existing vertical datum, in our case, NAVD88, okay? And so let's just look at these items here, these names. You see Geoid 03, 09, 12B, and 18. These you may be familiar with, probably 12B. I recommend moving to 18 with your new data collections. But each one of these was built on some existing gravimetric geoid. Now, these are the geoids. You do not want to be using one of these geoid models if your intent is to have your data, your GPS data in NAVD88. You'd be using one of these, okay? But that's the process. You take that gravimetric, you best fit it. So let's visualize that real quickly in cross-section. So we're looking at, here's our gravimetric geoid, right? We build that from gravity data. It's aligned to that topographic surface. And now we fit it and mash it to that existing NAVD88 reference surface. And we call that a hybrid geoid. Okay, so that's really the difference in the gravimetric versus hybrid. Gravimetric is our aligned to that topographic surface by nature, and then our hybrid geoid is when we mash it down to fit some other vertical datum or some existing vertical datum like NAVD88. Okay, I'm going to skip a couple slides because I'm running low on time, but I want to point out our current access to NAVD88. The official path is through conventional benchmarks, right? But you can always use Geoid 18. We support it. We built it for our users. So GPS data is kind of our unofficial path now, right? But we love it. It's great. But as we move forward to NetGD 2022, GPS data becomes our official path. The Geoid 2022 becomes our official path, leaving existing benchmarks or leveling to then become the unofficial path, okay? Because the datum itself will be based on satellite data, and so that becomes the official path is GNSS, okay? Of course, we will still offer transformations via NCAT. Of course. And so as I wrap up here, I'll point out some of our details on all this that I've talked about geopotentially, right, or vertically is available in our blueprint for 2022, part 2. We also have part 1 and part 3. These are on our website. There's also webinars that accompany each one of these, an hour webinar each. That's great to just listen to at some point. There's not a whole lot to watch, but just to listen and understand even those recorded webinars. I'm kind of running low on time, so I'm not really going to cover much of this, but I will say NAD83 is being replaced by NatRef 2022. Here is the map of change at the continental level. There's what it looks like in, this was from somewhere in North Carolina, I think, but really so you'll notice the horizontal shift is pretty consistent across the lower 48. So you're going to see about 4 feet of horizontal shift around Kentucky. That's what it'll look like. And this is just a screenshot from ArcMap, where the green line is some national shoreline data reprojected to NatRef. So it's something you'll notice with high-res imagery, but maybe not notice with satellite-level imagery. So let's get back to vertical and just look at the lower 48. The estimated change, right, in our ortho heights. That's what we, orthometric or ortho heights. So moving from NAVD88 to NetGD 2022, here's our overall lower 48. Let's just bring down the Kentucky area right there. So across Kentucky, you're going to see a vertical change of about 0.8 of a foot to about 1 3/4, 1.7 feet. And it's a downward shift. Okay, so it's a downward shift, non-uniform, right? So you're going to see these pockets, right? And some pockets here have changed, so you're really going to want to use NCAT for what it was designed for, right? And I'm running short on time, but I got a few other slides. I'm going to just real briefly say, I do recommend as we move forward into new datums and working in them, utilize complete nomenclature for any of your geospatial data. So I'll point out when you see this N8083 and then that number in parentheses, that's called your realization. And then you'll see that epoch afterwards, that's your reference epoch. The realizations are major realizations are listed right here. And that is important to know when you're looking at highly accurate data. If you're looking at data that's, half a meter, 2 feet, it really doesn't make a difference. Okay, when you're talking about centimeter level data or survey grade data, that's when your realization matters. And then looking at vertically, right, a vertical datum. Ideally, you would list somewhere in your data what geoid model you used to determine that NAVD88 value, okay? To be wholly, really detailed, you're gonna even wanna say what ellipsoid, which would be N8083 and your realization and epoch, okay? But at least start focusing on maintaining the geoid data with your NAVD88 data, knowing what geoid model was used, okay? I'm gonna skip over the water level. I'll point out real quick though, currently on our elevation certificates, which you may work with surveyors, engineers, or architects to fill out, you can always include more data than less, right? There's a minimum requirement for your elevation certificates from FEMA, but you can always add metadata, right, as notes too. Help, training resources. I'm closing in on my 11:45, but look at our find our homepage here. We've got a whole new page on our new datums. We've also got, if you look at our science and education tab, we've got these videos you can watch anywhere from 3 to 5 minutes, and then these 2 and 4 and 5 hour lessons. Never hesitate to reach out to us as your regional advisors, myself, or anyone else you feel. Our state geodetic coordinator, don't currently have one for Kentucky, but I've had discussions with Brian Bunch over at Kentucky Infrastructure Authority because Danielle Kelly, if you knew her, she retired from KYTC. And then there's a little push for our email subscriptions as we hit 11:45, and I'll wrap up here. I'll leave that up on the screen where you can see we have a few different options for email subscriptions. You look for this button on our website to find that. So I'll turn that back over to you, Caitlin, if we had any questions.
No questions in the chat right now. Did anyone have any pressing questions? We can probably answer one before we need to leave. Alrighty, join me in thanking Jeff. Virtual round of applause. I work in floodplain mapping, so this is all kind of right down my alley here. Great job. And I want to remind everyone we have a virtual happy hour tonight. We're doing a campfire stories. Should be a lot of fun, and check out the virtual map gallery. Thank you again, Jeff.
Awesome. Thanks, Caitlin. Thanks everybody for having me. Appreciate it.